In this episode, I'm going to restore a Pioneer SX434. That includes replacing capacitors that are bad and checking everything out to make sure everything's in proper operating condition. Let's check this out. So I've got speakers hooked up to it. Volume's turned to minimum. Power on. Okay, the controls need to be cleaned for starters. Turn the muting off. I don't have an antenna connected to it, so there's my test transmitter. Controls definitely need to be cleaned, but it is receiving FM. Volume control definitely needs cleaning. Sounds like the switches need to be cleaned. Let's try my AM. We'll try my AM transmitter at 1440.
Will be the renting, some 30%.
Move the antenna out from the back of the receiver a bit. Here's my test signal.
The Pacers.
Spot $1,700 is brought to you by
inventing the proprietary system that
You know, Wakama number 3 road, it has since been cleared, so not everyone agrees. Retail.
That's Tyler Sagan, and they do have
I got a lot of noise generating devices here that kind of wipe out the AM band, but it's working. We're going to hook up an FM antenna to this and see how it pulls in FM signals, the local FM station. I'm just going to clip a wire on here and see how it pulls in FM stations. And then we'll get the top off this thing and clean it and see what else it needs. I don't think this thing's going to need capacitors in it. You know, changing capacitors is overrated. And you get a lot of the so-called internet experts out there that say you got to change every cap, and that's just a load of crap. That was concocted by some shops that would make people believe that every capacitor is going to fail, and that's just not the case. They generally don't fail. The odd one fails. That's more of a modern problem with switching power supplies that operated at high frequencies and high temperatures, and accelerated the failure of some capacitors that were substandard from the factory. Better made ones don't fail, but back in the era of this one here, these ones here generally don't have a lot of failures on them. Okay, FM antenna is connected. We'll start down in the basement here and see what type of signals we can get.
Might be called the social revolution. Will this be more?
I've got the muting on, right? So it's going to mute the weak signals.
And hey again, Luke Combs.
New music. Imagine.
紧张没有关系，房子紧张。
Obtenu auprès d'un membre de la famille ou d'un ami.
Our fees are quickly reduced for quick.
Well, the dial calibration is exactly where it's supposed to be, so I won't need to change that.
Percent off. What? Oh, we're out of time.
No rain checks, conditions apply, financing on approved credit with your options MasterCard. Because there's up, and this isn't one person, this is every.
But turn the muting off.
Action thing going.
With less commercials.
Control the music on the KISS Radio app.
Take a seat.
Rock 101.
The United States, the state of Missouri.
Trans Mountain, qu'est-ce qu'elle va faire?
When chaos erupted on a Southwest Airlines plane yesterday, the cockpit was calm and focused. And we'll hear.
And then there's my test signal down here. So we're going to pull the top off this thing now, and I'm going to check it out, and we'll do things like we'll check the level and so forth, make sure that our levels are balanced between the two channels. Here's the view from the bottom. Some of these caps in here in the power supply probably could be replaced. Looking at this one here looks like it's kind of a bit, the jacket on it is kind of shrinking a bit, which generally is an indication that it might be getting close to going, so maybe change this one out. We'll measure them. I'm going to put the ESR meter on them, and we'll take a look at them and see how they look, because this one's a rebuild, right? So I can put some parts into this one. The parts that need to be replaced will be done, let's put it that way. So looking at this one here, that one there, probably a good chance a few of these ones will need to be replaced. I'm just looking at how to get at those controls to clean them, because of course they're behind the circuit board, so it could be fun to get in there with a cleaner without having to disassemble this thing any more than I have to. Well, the only way really to get at the controls to clean them is actually to completely disassemble the unit. So I'm taking the controls off the front now. I got to remove the front panel, and I'm going to have to remove that circuit board from the bottom, which is a lot more work than it looks because of the placement of that heatsink that goes right through the chassis there. So it's a little bit more involved to get at this to clean the controls, but really the only way to do it is to take it all apart. There's not really any other way to get in there with cleaner to clean it up. So while I've got that apart, I'll change out some of the coupling caps that are on that board, which are tough to get at because of the placement of the board itself. So we'll do that at the same time. As you can see, these ones were a lot of work to get at anything. To get that main board out, I actually have to remove the power supply board because there's another screw that goes into the heatsink from the bottom that's actually below that power supply board that I'm moving now. So I have to remove all these boards to get at this, and I got to take all the front controls have got nuts on them that have to be taken off too, so that I can work the board out. And it's a fair bit of work to do this. Like, I'm condensing this down on the video here, but this is a fair bit of work to take this thing all apart, to do it right? To get in here and clean the controls and do it right. This is what procedure you've got to go through. You've got to release these 3 plastic board anchors and get the board out of the way and kind of fold all these wires out of the way. Good units, but they weren't the easiest ones to work on, that's for sure. A lot of work on this thing just to take the thing out to clean the stupid controls. What a dumb design this is. Ah, man. Just to get this thing open so I can get some cleaner into the controls here, I have to take this whole thing all apart. What a silly design this is. Wow. Okay, let's get in there with a cleaner and clean the controls. So while I've got the board out, I've cleaned the controls now. While I've got the board out, I'm just going to take my ESR meter and I'm just going to go through and I'm going to check some of these caps in the audio circuit here, because this board is such a pain in the ass to get at. And some of these caps on here, you can't get at it without actually taking the board out. So I'm just going to go through. I'm going to look and see if there's any of these big filters and stuff in here have got bad ESR. That's 0.08, that was looking fine. So I'm just checking these. So far, none of these are jumping out at me saying that they're bad. A 330 at 25 over here. This is a 330 at 25. 0.07, that one's okay. And 220 at 25 is, where's that one? Is that this one? Yeah, that one's okay. So this one back here, 220 at 16 volts. So 220 at, should be like 0.33. And this one is coming up at, I was getting close. So that's the one that I suspected might need to be changed. 0.36. So 0.1, between a 0.09 and a 0.16. That one looks to be okay too. This one here, I'll swap out that one because that one there certainly, that one could be bad, or starting to get there. It hasn't gone bad yet, but just from looking at how the the wrap on here is kind of shrunk. Typically what's happening is the rubber plug is actually starting to push out, and it's starting to push up on the cap and start to expand it. So this one's actually raised up a bit on the board. That one's starting to go. We'll swap that one out. I've made the decision that I am going to swap out a few of the coupling caps in here, just because this board is so hard to work on, to take it apart, to work on this. For a couple caps, I'm going to change. I've got them, so I'm going to change some of the ones on here, the 47 and the 220 and so forth. I'll change the coupling caps in the preamp board, just because I have them, right? So might as well do it while I've got it apart. So that's one. One thing I will say is that my soldering iron is certainly working a lot better now that it's calibrated, and it's actually getting to 700 degrees. Okay, I've changed out 4 of the coupling caps. As you can see, a couple of them here looking like they're getting a bit dry. The other ones are all seem to be okay. This one here was a little bit questionable. So I changed out the 4 ones in the preamp and the coupling stage. We're also going to change out this one over here. I'm just going to put this board back in now. It's kind of tricky to get this in because you got to kind of angle it in and line up the heatsink. So it was a bit of a challenge to get this thing out, so I'm sure putting it back in is going to be just as much of a challenge. You know, some companies just have really dumb layouts, and this is going to be one of them. Because I got to get this heat sink in through a slot in the top and get all the wires around it. There, sort of. Okay, now I'm going to change out this other cap here on this power supply board. This little 220 16 volt unit here. So if we recheck the ESR, 220 at 16 volts should be 0.33 maximum for a new cap. This is an old one, and it is coming in at 0.21, so it hadn't even gone bad as far as ESR goes. Now we'll check our replacement cap here and see that our replacement one looks like it's faring worse than the original one. 0.28. So it's okay, but it's not measuring any, you know, it's not that much lower, if any. Here's another new 220 at 16 volts, 0.78. That one measures bad right out of the package. Try another one. So here's the third one, 0.84, 0.87. Two different, actually bought them at two different times, so they're in two separate bags. I had like one left. So yeah, the other one that's measuring like 0.2, this one, other one over here, this one here is going to go in because it's measuring lower, it's measuring within spec. But two brand new ones here are measuring higher than my ESR tester says they should be for worst case for a new cap. Okay, new cap is in. Just mount this board back down here where it belongs. Kind of get the wires out of the way. One. Okay, that's mounted. Put the screw back in, and now mount the controls, and we'll test this thing. See how it sounds. Okay, front face. Okay, all the knobs are back on. We'll just power this thing up and see what it does. Sounds like it's working. So now I'm going to do the channel of power balance to see if our channels are equal. So I'm in stereo mode obviously now. Turn that intensity down here because I'm burning this camera out here. Okay, so if I turn it to mono, okay, now we're just looking at a mono signal. Now what we want to see is we want to see this just as it is. Perfect 45 degree. If I turn it to the left channel of balance, it's going to go 100% horizontal. If I turn it to the right channel, it's 100% vertical. This is how we know our channels are balanced in mono, because we'll get equal deflection. Left channel, right channel. Back to stereo. So our power output is the same on both channels.
Has a bit of fizz.
As you can see, my little MP3 test transmitter certainly doesn't have the separation of a real station. Okay, what we're looking at now is we're looking at the left channel and the right channel. We're looking at the difference between the two in mono. So as I roll the balance control, of course, now we're seeing like left minus right. So the middle trace will copy the bottom trace. Same with the top trace. It's basically looking at the same thing, right? I put it in stereo mode. Now we're seeing the different signal. This would be like your surround, like left minus right. So that information will be what will be going to your surround speakers, because what I'm doing is I'm adding the signal together, but I'm adding it to an inverted channel too. If I turn off the invert, it's now this will be the mono signal, right? This is the sum. This would be the sum signal, right? Now it's adding the two signals together, and if I hit invert, now it's subtracting, so this is just a different signal. So if I turn off the invert, for example, and I put it in mono, right, we're seeing the same signal added together. If I hit the invert button, now we're not seeing it. And if I go back to stereo, now we're getting a different signal. You guys might be wondering why we're seeing some noise here. I think if I turn off my AM transmitter, that'll probably go away. There, see? On, off. That bit of noise I was picking up here was actually from the 400 milliwatt AM transmitter, which the antenna is right behind me here, that I use for testing. So that's where sometimes you're looking at my scope readings and I'll forget and leave that thing turned on. I actually had it on because I was testing this, but I'll have it on and you'll see noise, but it's not noise. It's just my probes are picking up some RF from like things like the speaker leads, because this is just hooked up to the output of the amplifier. So there's stereo. This thing sounds great. The owner of this receiver is going to be really happy with it. And as you can see, all I've done is I've just connected my scope to the speaker terminal. So what I was looking at there is I was looking at the amplifier outputs, and everything's balanced. Levels are equal for both channels. Everything's tracking perfectly. Now I can put this unit back together, get it packaged up, and get it ready to ship back. Actually, I guess I'll be waiting for the client to come and pick it up because he dropped it off, and he'll be coming back in a couple weeks to collect it from me. Okay, one final test. It's FM, AM. You can sure tell that the AM receiver, the AM section in this isn't anywhere near as good as the AM section in that big console, but that's par for the course. Back in the late 60s and even into the early 70s, AM radio was still very big for music. So the older AM radios generally sounded a lot better than the more modern ones, where they got very selective and very sensitive, but they really cut the sound quality. They narrowed the bandwidth quite a bit. Some of the old ones from the pre-FM days, or when FM was really quite new, they had really good sound on them. In fact, I think that Grundig radio that I had, it actually had an adjustable bandwidth, and there was a dial on the front, and you could adjust the actual bandwidth and really widen out the AM, and it would go right to like 10 kilohertz and beyond. And the AM stereo radios have a wideband mode on them as well to give them good sound, but regular AM don't sound very good. But then, who listens to AM, right? Nobody. Anyway, that's it. Thanks for watching. We'll catch you again in the next one. So this one here, clean the controls, 5 caps, 1 in the power supply, and 2 each in the left and right channels, coupling caps, interstage coupling. We'll catch you in the next one. Thanks for watching.